Guys, we're going to have an input here of -2. Let's plug it in. Make sure you use your parentheses because it's negative. So we're going to have -2 to the third power minus 5 times that -2 squared minus 11 times -2 plus 8. Do your order of operations. So remember, that's going to be a -8. See the C equals -2? We're just working through an example. Are you on page 25? Oh yeah, we were flipping back and forth. Go back to page 25. Now do you see?
No.
Okay. All right, so while we plug this in, we have a -8 and then a -5 times a 4. That's going to be a -20. I'm going to bring down the rest of my work from the previous line. What does that simplify to?
2.
A 2. That's right. So, guys, remember we had an input of -2. This gave us an output of +2. Y'all, which means if I pulled up Desmos and put this on the graphing calculator, this would be a point on the graph. Now watch this. Give yourself a little divider. Let's pretend I was doing synthetic substitution. I'm going to put a -2 right here. Draw my upside down box. Now let's do the synthetic substitution. Let's put these coefficients right here. So we have a 1, a -5, -11, and an 8. So now we're going back to the stuff from yesterday. This right here, this better equal a negative or a +2. What I got here better be right here. Let's see if we get this answer. Let's pull down our first number and just go ahead with our synthetic substitution. What do you get? What did we get here? What did we get here? That's the remainder theorem, guys. That's all that is. That's why synthetic division is so important, because you're finding your x-intercepts. We're just so happy that we get 0 because we found an x-intercept. Sometimes we don't. Y'all, it's still just an input and an output.
So it's just with substitution or the polynomial?
You can substitute with polynomials, just polynomials, yes. Synthetic division deals with polynomials. All right, so one more thing down here where it says the remainder theorem. Remember, it is synthetic. Yes. Oh, yes.
So the remainder is the x or is this an input?
The remainder gives you the output. What we plugged in was the x value. But if I get a remainder, if I don't get a remainder of 0, if I do get a remainder of 0, if I do not get a remainder, there's nothing left over. That's the x-intercept. Let's practice that. Y'all turn to the back of page, go to the back on page 26. All right, so here we go. We are going to practice this, and we are totally just analyzing remainders. So let's read number 3. Use the factor theorem to determine if the binomials given are factors of f of x. Then use the binomials that are factors to write the factored form of f of x. What we're going to do is we're going to do synthetic division twice. We're going to do it once for this with that one. We're going to do it all over again with this, with the same numbers. So in this space down here, guys, this is what you need to write. You need to write your 2 upside down division boxes with these factors. Now remember, when we're dealing with factors, look, you put the opposite sign. We're testing x minus 1. Look how I put a plus 1 there. We're testing x plus 3. Look how I put a minus 3 there. Let's test out these binomials. Remember, you always test the opposite with synthetic division. Any questions on why my paper looks like this? All right, let's go. All right, I'm going to try this first binomial. Let me bring down my 4. We're just going to work through this, get our little numbers here. 1 times 25. That's 50. 1 times 50. 1 times 45. Guys, are we happy on this? No, we are not happy. What is the remainder? 48? That makes me so sad because it's not a factor. But 148 is on the graph. That's what that means. But it's not a factor. And remember, we are in the business of finding factors. Let me try this one. Let's try all over again, guys. Bring down your 4. Work through your stuff. Ooh, are we happy over here?
Yes.
Yes, yes, yes. How come? It's a 0 for a remainder. Good. We found a factor. We found 2 factors. We know that x plus 3 is a factor. You also know your answer is a factor. Y'all, what's the exponent for my answer? What does this exponent start with? 3. Remember, it's always 1 less. Good. Plus 9x squared minus 2x plus 1. Yay! All factors. Okay, there's something, y'all, there's built-in checks to make sure you did this right. Look at the polynomial again. Look at that big giant polynomial on 3a. What was the highest degree again? Good. I have a degree of 1 here. I have a degree of 3 here. What's 1 plus 3? All right, so far so good. The only thing that I need to do now is I need to check to see if this is factorable. Maybe I can keep going, maybe I can't. Let's try to check it out. My answer had 4 terms. The only way I can try to factor is by grouping. Let me write my answer over here. It doesn't factor, guys, but I just want to show you, I just want you to check. So I'm going to do 2 groups. What can I take out of this first group? Yeah. What's going to be in here? 4x plus 9. There is nothing I can take out of this to make those numbers turn into a 4x plus 9. So it's not factorable, but you always have to check.
So is the factor there just checking if these 2
So here's the factor theorem. The factor theorem says to you, you have absolutely found a factor for a giant polynomial if you don't get a remainder. That's what it says. If you get 0 at the end of your synthetic work, that last number, the factor theorem tells you you have found a factor for that polynomial.
Okay, so it's giving us two possible factors and we're supposed to figure out which one it is.
And sometimes they both will work, but in this example, only one of them gave us an answer of 0.
So whenever we do factor theorem and remainder theorem, we're always factoring our answer.
You are always doing synthetic division and analyzing the remainder. If the remainder is 0, it's a factor. If the remainder is not 0, then it's some output on the graph. Right?
For example, right there, I'm trying to do the 4x cubed whatever.
Yes.
Turned out not to, so we always take that extra step.
Oh, yes.
And factor that last one.
Yes. The answer to that question is yes, absolutely. All right. So let's try again, guys. Great questions. Let's keep going. Let's look at 3B. All right, so look at 3B. First of all, look at the polynomial, not your phone. Look at your polynomial. Do you have any missing degrees in that polynomial? No, so you're not going to have any zeros for placeholders. So draw your upside down division boxes and put those opposite numbers on the outside. The inside top row is going to be the same. Here's your setup. Check to see that you did your setup correctly. Who? We're happy on both of them, right? No remainder on either one of them? Okay. So, let's talk about this. We know on this side, when I tried x plus 4 is a factor. So is 2x squared minus 9x minus 5. Both of those are factors. But are they factored completely? Hello, you have a factor drill tomorrow. Are those factored completely? They are not factored completely. You need to keep going on this for sure. We are in the business of completely factoring these polynomials. The directions said that. Factors of negative 10 that make a negative 9 are a negative 10 and a positive 1. So on this side, when I completely factor everything, when I tested x plus 4 I get these factors. Y'all look at your packet. What was the highest degree of the polynomial on B? 1, 2, 3. Completely factored. But I got a different answer over here. Let's see. Let me go over here. So I know x minus 5 is a factor, y'all, because we got 0. Let's look at this polynomial, this answer. 2x squared minus 9x plus 4. Thank you. They're all pluses. Yes, yes, yes. Is this factorable? I don't know. Let's see. 2 times 4 is 8. Oh, I think it is. What are those magic numbers up here? 1 and 8. Don't forget, what are we dividing by? 2. So x minus 5, 2x plus 1, and x plus 4. See how you get the same factors? They're out of order, but they're the same factors. We tested one polynomial twice. You just told me that polynomial had a degree of 3. 1, 2, 3. 1, 2, 3. Same thing. Any questions on that? So what if B was a quiz? What if I said, hey, here's a couple of factors. Are they both factors? You would write yes. What if I asked you what the factored form was? You would just write these once. These are not repeating. So it's completely factored. With each of these written one time. X minus 5 and x plus 4 was a factor. And don't forget the other one we found, the 2x plus 1, which we only got by factoring the final answer. So yesterday's stuff is really just like today's stuff. You just have to check to make sure your quotient can be factored. Let's keep going. Let's look at C. I already have it set up. So you do it before me. Okay, let's see. Nice, 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 nice. know what this is in my head. Is that a, let's see. Thank you. I don't know this in my head either. Say again? I know that's not gonna, I'm gonna stop. See, that's why it makes me so sad. Not only is it not a remainder, the answers get ugly, I can't do it in my head. Alright, so let's take a look at what's going on here. So we know x minus 2, awesome. And then 9, 1, 2, 3. So 3x squared plus 5x minus 12, awesome. Are we finished? That's right. You better see if that's factorable. It is. It is factorable. Y'all, Miss Harrington lost a highlighter. Do you see it? So sad. I'll find it like in 2 years. That's okay. Okay. All right. So guys, that's going to be just x plus 3. And that's going to be 3x minus 4.
Is there like a proper order divided in? Or can we write it like
Any order. Any order. Any order. Nope. No proper order. What else was I going to say? Oh, just one more time. Check your degrees. What was the degree of the polynomial?
2.
The original one. The original one was 3. 1, 2, 3. Awesome. All of my degrees are accounted for. All right, cool. That's all I got. Any questions on this? Okay, what time y'all get out of here? At the 40?
Yeah.
So you guys don't have homework. You have right now work. This is your right now work. Guys, hop over to page 28 and do the back. Page 28, do the back of page 28. And I'm gonna put up a key, a worked out key, just to make sure, to help you make sure you're on the right track. So the back of page 28. Say again? On what? Oh, thank you. Yeah, no. Somebody's going to suffer.